Imagine this. A tiny flicker of light appears deep within a cloud of cosmic dust. A spark so small you'd miss it if you blinked. But over millions of years, that spark will ignite, burn hotter than anything we can imagine, and eventually die in one of the most spectacular explosions in the universe. A supernova. That's the life of a star, a cosmic story of birth, glory, and death. Today on Cosmos Unlocked, we'll travel through billions of years to witness the life cycle of a star. From its first heartbeat in a stellar nursery to its final breath as a black hole or a white dwarf. So, buckle up. We're going on a journey through time, space, and stardust. Our story begins in the dark, inside vast clouds of gas and dust called nebulae. Here, gravity begins to pull matter together, tighter and tighter, until the temperature at the center skyrockets to millions of degrees. When nuclear fusion ignites, hydrogen atoms fusing into helium, a star is born. This newborn is called a protostar, and it shines for the very first time. Over time, it enters its longest and most stable phase, the main sequence. This is where stars, including our Sun, spend about 90% of their lives burning hydrogen into helium in their cores. The size of a star at birth decides everything: how long it will live, how it will die, even what it will leave behind. Small stars like red dwarfs can live for trillions of years, slowly sipping on their fuel. Medium stars like our Sun live around 10 billion years, and massive stars, they burn their fuel fast and die young, sometimes in just a few million years. As fusion continues, hydrogen in the core runs out. Gravity wins again, and the star begins to collapse. But just before it dies, something dramatic happens. The star fights back. When hydrogen is gone, it starts fusing heavier elements, helium into carbon, carbon into oxygen, layer after layer, like an onion made of fire. For a star like our Sun, this phase turns it into a red giant, so large it could swallow Mercury, Venus, and maybe even Earth. Eventually, the outer layers drift away into space, creating breathtaking planetary nebulae, glowing shells of gas. What's left behind? A small, dense core, a white dwarf, no bigger than Earth, but containing half the Sun's mass. Over billions of years, it cools and fades, becoming a black dwarf, a silent ember in the dark. But for massive stars, the ending is far more violent. When they run out of fuel, their cores collapse in less than a second, triggering a supernova, one of the most powerful explosions in the universe. For a brief moment, that dying star can outshine an entire galaxy. What remains is either a neutron star, so dense that a teaspoon of it would weigh as much as Mount Everest, or, if the star was truly enormous, a black hole, where gravity is so intense that not even light can escape. But here's the most beautiful part. That's not the end. The explosion of a dying star scatters its elements across the cosmos: carbon, oxygen, iron, the very ingredients for new stars, new planets, and life itself. In fact, every atom in your body was forged in the heart of a long-dead star. So next time you look up at the night sky, remember, you're not just looking at stars, you're looking at your ancestors. If you enjoyed this journey through the cosmos, hit that like button, subscribe to Cosmos Unlocked, and ring the bell so you never miss your next trip among the stars. Until next time, keep your eyes on the cosmos.